Hey everyone, why do we always come back down when we jump? Why doesn't a ball just keep flying into space? The answer is gravity, the invisible force that keeps us grounded and holds the universe together. Gravity is everywhere, affecting everything from tiny dust particles to massive stars. Even you, your pet, and your chair have gravity. But Earth's gravity is what you feel every day. It's what gives things weight and makes dropped objects fall to the ground. Gravity isn't just about keeping us on the ground, it shapes our solar system and the universe. The same force that pulls an apple from a tree keeps the moon orbiting Earth and Earth orbiting the sun. Without gravity, there would be no planets, no stars, no galaxies, just floating particles. So how does gravity work? Why does it exist? These are questions scientists have explored for centuries. The story of gravity is filled with brilliant minds and revolutionary discoveries. Let's take a journey through time and space to uncover the science of gravity. Consider this your invitation to explore one of the universe's greatest mysteries. Let's get started. Our story begins in ancient Greece with Aristotle, who thought heavier objects fell faster than lighter ones. This idea lasted nearly 2,000 years, until Galileo put it to the test. Legend says Galileo dropped two balls of different weights from the Leaning Tower of Pisa. Both hit the ground at the same time, proving weight doesn't affect how fast things fall. Galileo showed that all objects accelerate toward Earth at the same rate, unless slowed by air resistance. A century later, Isaac Newton saw an apple fall and wondered, could the same force pulling the apple also keep the moon in orbit? Newton realized gravity is a universal force. Every object pulls on every other object. His law of universal gravitation explained why apples fall, planets orbit, and galaxies hold together. Newton's ideas changed our view of the cosmos forever. So what was Newton's big idea? The law of universal gravitation. First, gravity's strength depends on mass. The more mass, the stronger the pull. That's why you stick to Earth, not a basketball. Second, gravity weakens with distance, following the inverse square law. Double the distance, gravity is 4 times weaker. This explains why astronauts feel weightless in space. They're far enough from Earth that gravity's pull is much weaker. The moon doesn't crash into Earth because it's moving sideways fast enough to keep falling around Earth in orbit. Imagine throwing a baseball so fast it never lands. That's what the moon is doing. During Apollo 15, astronaut David Scott dropped a hammer and a feather on the moon. With no air, both hit the ground at the same time, just as Galileo and Newton predicted. This proved the laws of gravity work everywhere, not just on Earth. Newton's law let us predict orbits, tides, and more. It stood as the foundation of physics for over 2 centuries. Science is amazing. Let's see how our understanding evolved even further. For centuries, Newton's laws explained gravity, until Albert Einstein changed everything. Einstein proposed that gravity isn't a force but the result of massive objects curving space-time itself. Picture space-time as a stretched rubber sheet. A heavy ball creates a dent, and smaller objects roll toward it, not because they're pulled, but because they follow the curve. Einstein's theory of general relativity predicted that gravity could even bend light. In 1919, astronomers saw starlight bend around the sun during an eclipse, proving Einstein right. His theory also predicted black holes, regions where gravity is so strong not even light escapes. Black holes are like bottomless pits in space-time. While Newton's laws work for everyday life, Einstein's relativity explains the universe's most extreme phenomena. This revolutionized our understanding of space, time, and gravity. The universe became stranger and more fascinating than ever imagined. Let's see how gravity shapes our daily lives. Gravity's effects are everywhere, even in the ocean's tides. The moon's gravity pulls on Earth's water, creating high and low tides as our planet rotates. Gravity also keeps satellites in orbit. They're launched fast enough to keep falling around Earth, just like the moon. Satellites give us GPS, weather forecasts, and global communication, all thanks to gravity. To escape Earth's gravity, rockets must reach speeds over 25,000 miles per hour, showing just how strong gravity is. Astronauts floating in the International Space Station aren't beyond gravity. They're in freefall, orbiting Earth together with the station. Gravity is still about 90% as strong up there as on the ground. Because everything falls together, astronauts feel weightless, like the brief moment at the top of a roller coaster. Gravity shapes our technology, our oceans, and even our sense of up and down, but gravity's mysteries go even deeper. Even after Newton and Einstein, gravity still holds secrets. Of the four fundamental forces, gravity is the weakest, yet it shapes galaxies and the universe. Why is gravity so weak? No one knows for sure. Gravity can even slow down time. Clocks run faster in weaker gravity, a fact proven by GPS satellites. From forming stars and galaxies to shaping the universe's fate, gravity is the silent architect of everything we see. Every falling leaf, every orbiting planet is part of gravity's cosmic dance. Our journey to understand gravity has taken us from apples to black holes, and there's still more to discover. Next time you drop your keys, remember, you're witnessing the universe's most persistent force in action. Gravity connects us to the cosmos and inspires endless curiosity. What will you discover about gravity next? Let's keep exploring together.